Starting a simple collection and sample preparation area of our class. Simple preparation takes two-thirds of time of an analytical technician, while analysis itself takes only one-eighth of time. One quarter goes for report preparation and data analysis. Despite that, most of attention in all publication and textbook you can find is dedicated towards analysis, while if you do something wrong with sample collection or sample preparation, your analysis is useless. Garbage in, garbage out rule works perfectly well in this case. So we'll quickly look at uh, to start with. Of course, in ideal case, you can find pure poison somewhere outside of human body and then identify it as quick as you can. But this luxury doesn't happen often. So most common samples are blood related, and we know why from pharmacokinetics and pharmacodynamics. We know that blood connects all the tissues, all the areas of human or animal body. So by studying blood, we theoretically can see everything. Now, just a reminder, blood can be arterial, very difficult and dangerous to collect. You can kill person. A very close mimic of arterial is capillary blood, just pricking finger, collecting several drops. If you need large volumes, venous blood is very common. Well, collecting blood from dead people, it's a separate story. You can look in your textbook about that. Now, we can process whole blood, so all the cells, all proteins, all compounds taken together. Very difficult to handle because it will coagulate on standing. But sometimes, yes, it would be necessary. Sometimes we specifically need to analyze cells in blood. That's separate. Now, very common blood samples are serum. What are these? It's just blood left standing on its own, so you have blood clot, and above that is almost colorless liquid we name serum, and actually its volume is smaller than total volume of all the blood. So that's what you had before, that's what you had after. Otherwise, what we do, we add anticoagulant and then centrifuge our blood at around 2000 G. As a result, we have three layers: a red layer of red blood cells, almost one half of volume, a thin layer of white blood cells and platelets and some proteins, and then we have around half of volume being yellowish plasma, still containing lots of protein, and of course anticoagulating agent. What kind of anticoagulants we use? Two different salts of heparin. Heparin, anticoagulation compound. If they suspect you have a stroke, they'll inject you heparin. It prevents formation of blood clots. It can be lithium, heparin, mainly for cases when you want to analyze for alkali metals like sodium. Most common is sodium heparin. Then more exotic sodium fluoride, sodium citrate, or EDTA. Sometimes combination of these two. So we add anticoagulant and do centrifugation. Or is it receiving plasma stabilized with anticoagulant? This plasma can be stored for a reasonable time and then analyzed. What other specimens? Very helpful for volatiles, breath air. Urine is very convenient. These two are non-invasive, so fantastically easy. Stomach content, vomit, whatever related to stomach. Relatively non-invasive, hair, nails, tissue, well, only if it was surgery, but can be with. Lots of option in postmortem work. Oh well, you can swab skin. You can take saliva. Taking saliva, the easiest way you're putting cotton and then ask a person to chew it. It will collect around 1 ml of saliva. There are different approaches to do that. There are actually special ampulas for collecting saliva. Some possible problems, say problems with relatively dirty containers. Now, when dirty, it means it was not washed specifically before usage with some special cleaning agent. This case shows manganese concentration of serum stored in washed and unwashed polyethylene containers. So unwashed means clean coming from manufacturer. And as you can see, we have a very large discrepancy between numbers, but numbers around half a nanogram per ml. Actually, concentration is much smaller. If it was clean before, you have something like less than zero point 0.1, less than 6 times smaller number, with much smaller standard deviation. So all the manganese was from contamination. You actually measured nothing in unwashed container. Storage of this sample can present lots of challenges as well. Its common misconception is that metabolism stops when you removed the sample from human body. It's not true. Enzymes are still in plasma, so you have the samples here, and you have nitro azepam with nitro group here that can be metabolically reduced to H2N. So NO2 to H2N. Now, it happens in living body, so around one half, in some cases more than one half, of nitrazepam is already metabolized. But after storage of 10 days in a fridge, most of nitrazepam was metabolized further. So in some cases you practically have no nitrazepam left. The analysis after waiting time doesn't give you the right picture. That's fantastically common, and it's very important taking into account usual backlog of analytical labs.